Good afternoon, everybody. I am M. Priyadarshini, Department of Mathematics, Sri Shanmuga College of Engineering and Technology, Salem. I am going to discuss about the topic is Operations Research. Introduction. Operation research is an art and science. It had its early roots in World War II and is flourishing in business and industry with the aid of computer. Primary applications areas of operations research include forecasting, production scheduling, inventory control, capital budgeting, and transportation. The next one is what is operation research? Operations is nothing but the activities carried out in an organization. Research is the process of observation and testing characterized by the scientific method, situation, problem statement, model construction, validation, experimentation, candidate solution. Operations research is a quantitative approach to decision making based on the scientific method of problem solving. The next one is what is operations research? Operations research is the scientific approach to execute decision making which consists of three. First one is the art of mathematical modeling of complex situations. The second one is the science of the development of solution techniques used to solve these models. The third one is the ability to effectively communicate the results to the decision maker. Next one is what do we do? Our professionals aim to provide rational basis for decision making by seeking to understand and structure complex situations and to use this understanding to predict system behavior and improve system performance. Much of this work is done using analytical and numerical techniques to develop and manipulate mathematical and computer models of organizational systems composed of people, machines, and procedures. The next one is terminology of operation research. The British Europeans refers to operational research, the Americans to operations research, but both are often shortened to just OR. Another term used for this field is management science. In US, OR and MS are combined together to form OR or MS or ORMS. Yet other terms sometimes used are industrial engineering and design science. The next one is operations research model. It have two models. First one is deterministic model and the second one is stochastic models. Deterministic models having five models. First one is linear programming, second one is network optimization, third one is integer programming, fourth one is non-linear programming, fifth one is inventory model. Stochastic models contains seven models. First one discrete time Markov chains, second one continuous time Markov chain, third one queuing theory, fourth one decision analysis, fifth one game theory, sixth one inventory model, seventh one simulation. The next one is what are the difference between deterministic and stochastic models? Deterministic models assume all data are known with certainty. Stochastic models explicitly represent uncertain data via random variables or stochastic processes. Deterministic models involve optimization. Stochastic models involves characterize or estimate system of performance. The next one is history of OR. OR is a relatively new discipline. 70 years ago, it would have been possible to study mathematics, physics, or engineering at university. It would not have been possible to study OR. It was really only in the late 1930s that operations research began in a systematic way. The next one is problem solving and decision making. Seven steps of problem solving. First five steps are the process of decision making. First one, identify and define the problems. Second one, determine the set of alternative solutions. Third one, determine the criteria for evaluating the alternatives. Fourth one, evaluate the alternatives. Fifth one, choose an alternative. Sixth one, implement the chosen alternative. Seventh one, evaluate the results. The next one is quantitative analysis and decision making. Potential reasons for a quantitative analysis approach to decision making. The problem is complex, the problem is very important, the problem is new, the problem is repetitive. The next one is problem solving process. The diagram represents the how to solve the problem. Goal: solve a problem. Model must be valid. Model must be trackable. Solution must be useful. The next one is the situation. May involve current operations or proposed expansions due to expected market shift. May become apparent through consumer complaints or through employee suggestions. May be a conscious effort to improve efficiency or response to an unexpected crisis. For example, internal nursing staff not happy with their schedules, hospital using too many external nurses. The next one is problem formulation. Describe system, define boundaries, state assumptions, select performance measures, define variables, define constraints, data requirements. For example, maximize individual nurse preferences subject to demand requirements. Next one is data preparation. Data preparation is not a trivial step due to the time required and the possibility of data collection errors. A model with 50 decision variables and 25 constraints could have over 1300 data elements. Often a fairly large database is needed. Information system specialists might be needed. The next one is constructing a model. Problem must be translated from verbal, qualitative terms to logical, quantitative terms. A logical model is a series of rules usually embodied in a computer program. A mathematical model is a collection of functional relationships by which allowable actions are delimited and evaluated. For example, define relationship between individual nurse assignments and preference violations. Define trade-off between the use of internal and external nursing resources. The next one is model development. Models are representation of real objects or situations. Three forms of models are ionic, analog, and mathematical. Ionic models are physical replies of real objects. Analog models are physical in form but do not physically resemble the object being modeled. The next one is mathematical models represent real world problems through a system of mathematical formulas and expressions based on key assumptions, estimates, or statistical analysis. The next one is advantages of models. Generally, experimenting with models requires less time, is less expensive, involves less risk. The next one is mathematical models. Cost or benefit considerations must be made in selecting an appropriate mathematical model. Frequently, a less complicated model is more appropriate than a more complex and accurate one due to cost and ease of solution considerations. The next one, relate decision variables with fixed or variable parameters. Frequently seek to maximize or minimize some objective function subject to constraints, or said to be stochastic if any of the uncontrollable inputs is subject to variation, otherwise are said to be deterministic. Generally, stochastic models are more difficult to analyze. The values of the decision variables that provide the mathematically best output are referred to as the optimal solution for the model. The next one, solving the mathematical model. Many tools are available as discussed before. Some lead to optimal solution, other only evaluate candidates, trial and error to find best course of action. Example, read nurse profiles and demand requirements, apply algorithm, post processes, result to get monthly schedules. Model situation involves identifying the values of the decision variables that provide the best output for the model. One approach is trial and error, might not provide the best solution inefficient. Special solution procedures have been developed for specific mathematical models. Some small models or problems can be solved by hand calculation. Most practical applications require using a computer. Model testing and validation. Often, the goodness or accuracy of a model cannot be accessed until solutions are generated. Small test problems having known or at least expected solutions can be used for model testing and validation. If the model generates expected solution, use the model on the full scale problem. If inaccuracies or potential shortcomings inherent in the model are identified, take corrective actions such as collection of more accurate input data, modification of the model. The next one is examples of OR application. Rescheduling aircraft in response to grounding and delays. Planning production for printed circuit board assembly. Scheduling equipment operators in mail processing and distribution centers. Developing routes for propane delivery. Adjusting nurse schedules in light of daily fluctuation in demand. Application areas: strategic planning, supply chain management, pricing and revenue management, logistic and site location optimization, marketing research, scheduling, portfolio management, inventory analysis, forecasting, sales analysis, actioning, risk analysis. Examples: British Telecom used OR to schedule workforce for more than 40,000 field engineers. The system was saving $150 million a year from 1997 to 2000. The workforce is projected to save $250 million. Sears uses OR to create a vehicle routing and scheduling system which to run its delivery and home service fleet more efficiency, $42 million in annual saving. UPS used OR to redesign its overnight delivery network, $87 million in saving obtained from 2000 to 2002. Another $189 million anticipated over the following decade. USPS uses OR to schedule the equipment and workforce in its mail processing and distribution centers. Estimate saving in $500 million can be achieved. Why? Sorry. What you should know about operations research. How decision making problems are characterized. What terminology, what a model is, and how to access its value. How to go from a conceptual problem to a quantitative solution. Thank you very much.